Hello everyone. In today's session, I'm going to discuss few problems from GTA 1, the Grand Test for Advance 1, held at Sri Chaitanya. These questions were actually sent to be my students, which makes this session more meaningful and more interesting. Because whenever students bring doubts, it gives a real insight where the actual challenge lies. Not just what is difficult, but why it feels difficult. So in this video, I will not just solve the problem, but also walk you through, as far as possible, the thought process behind each step. My goal is very simple here. It is to provide you with the most clear, intuitive, and effective approach possible. That's something you can carry forward into your own problem solving. So take a notebook, stay focused, and let's dive into these questions together. Let's begin. All right, so you can give an attempt to this question before you see the solution. Question says that if x is a positive number, a sequence xn of real numbers is defined as follow. The x1, the first term of the series or the sequence, is half x plus 5 by x. The second term is half times x1 plus 5 by x1. And in general, xn plus 1 is half times xn plus 5 by xn. Then which of the following is correct? So let's go by the options one by one. Let's try the first part, the part A. You notice there, then we try to make it telescopic. If it will be successful or not, we don't know. So let's first try. I have the xn plus 1 is equal to half times xn plus 5 by xn. I can multiply 2 both sides, so we'll get 2 times xn plus 1 is equal to xn plus 5 by xn. Now I can multiply the entire equation by 2 to the power n. Why so? Because this will become 2 to the power n plus 1 xn plus 1. And this is 2 to the power n xn, and here 5 times 2 by x to the power n I can write. In this way, what we did, we made the series telescopic. How? I can bring this to the power n xn left hand side, so 2 to the power n plus 1 xn plus 1 minus 2 to the power n xn is equal to 5 by 2 by x to the power n. You notice we have to find out the value of xn. It means if you are successful to find out the xn plus 1, it is sufficient because by substituting n with n minus 1 in the same equation, we can find out xn and we can use it directly. But I think that we have done some kind of a messy step here, because this series will not provide you such easier version of the requirement, easier version of the expression what is required in the options. Because if you have to find out xn plus 1, you can make the telescopic by summing it up. So you'll get summation 2 to the power n plus 1 xn plus 1 minus 2 to the power n xn. And when n goes from, or k goes from, let's say this is k here, let's make it k. So if I make it k here, 2 to the power k plus 1, and this is k. And here also 5 2 by x to the power k. And this is also summation k goes from n, this is k goes from n, 1 to n. So if you do this thing, the left hand side will leave the first term and the last term, means the value at the n and the value at the 1. So this will give you 2 to the power n plus 1 x to the power, this is k plus 1 by the way, n plus 1 minus 2 to the power 1, that is 2 x1. And here you notice that 2 by x to the power k will produce the GP sum. 5 will be factored out, and this is a GP of n terms whose first term is 2 by x, and the common ratio is also 2 by x. So we can write 2 by x and then 2 by x to the power n, because n number of terms we are adding up, and divided by 2 by x minus 1. And after that we can do some massive calculations and we could get, but I don't suggest that this is the easiest one or easy or the smart move to handle this question. If I had to find out xn in this kind of a structure, we could do it. But now you observe carefully that A, B, C, D, all the options I have, especially the option A, is in this structure. This is xn minus root 5 and xn plus root 5. So instead of doing this thing, we could directly try to find out what is the value xn minus root 5 by xn plus root 5 leads to. So I'm going to do that thing, and for that I'm avoiding this thing here. So this is not working. I'm saying that not working because it will take a lot of time to calculate. So let's try a different way. I have not solved this question before the recording of this video, so I'm doing it almost live. So let's think here. So this is the part A I'm going to do again, because xn minus root 5 is here. So let's find out xn minus root 5. So since xn plus 1 is given, I can directly use xn plus 1 minus root 5, and then whatever expression I get after that, in that expression I will substitute n is equal to n minus 1. So instead of finding xn, I can find xn plus 1. So xn plus 1 minus root 5, it means half of xn plus 5 by xn minus root 5. By the way, this is the better way I suggest, because I'm guessing that this will work. So this is going to be xn squared plus 5 by xn and minus root 5, not xn, that is like this. If you take the LCM, what we get is half is out from each of the terms, so I can take it as x to the power, xn square plus 5 and minus 2 root 5 xn. Yes, is it correct? Yes, and divided by xn. So this is now half xn, and this I can write as xn minus root 5 the whole square, and that saves our life. In the same way, the denominator, that is xn plus 1 plus root 5, I can write half of xn plus root 5 the whole square. And you notice that the ratio, when I'm going to take the ratio, that half xn in this one will get cancelled. So what I got, the ratio is xn plus 1 minus root 5 by xn plus 1 plus root 5, and that ratio will turn into xn minus root 5 by xn plus root 5 the whole square. And you notice carefully, if I assume this as a new kind of a term, un plus 1, so this will be the un. So basically what is happening here is un plus 1 squared is equal to un squared. And so I can write, if you understand carefully, this I can write un squared is un minus 1 squared. And by the same process, I can write un minus 1 whole square, means un minus 1 square, as un minus 2 square and the whole square. And this will be iterated up to the first term. This is going to be to the power 2. Now, suppose you want to write un minus 2 again, that is going to be, by the way, here why I wrote the square, this is not square, and un minus 2 is what? Un minus 3, again square, and un minus 3 to the power 3, means 8 actually. So you got the idea that if I'm taking n minus 3 here, the value is getting, the power is getting 3 here. So try to understand the iteration. I'm subtracting 3 from the n, the power is 3. I'm subtracting 2 from the n, the power of 2 will be 2. So I have to go till the first one, because the answer is in terms of, you see that here, this answer is in terms of the first term here. You can notice, where do we get x minus root 5 by x plus root 5? If I get the first term, if you put n is equal to 1 in this, we get n is equal to 0, by the way. In this right hand side, if I have n is equal to 1, then I'll get it. And is 2 to the power n will come automatically. So what I mean to say, that I'm getting un is equal to, and if I iterate up to n there, means u naught is equal to, u naught to the power n. And what is u naught? When the subscript had not started, u naught is the expression what we see, which is actually building up the first term. And where the expression u naught here, this expression is the u naught, which is going to contribute. So this is going to be the first option, because you can see the C option has 2 to the power n by 2. By any chance, it is not going to be the C option. So first option is correct. Now go for the B part. For the part B, what we can see, that I have already an iteration relation or recursion relation. Xn plus 1 is half times xn plus 5 by xn. And notice that when limit n tends to infinity, limit n approaches infinity, xn I have to evaluate. Let's assume that this limit is limit L. Now notice, when you have to find the limit n tends to infinity, in this xn, all are providing a positive quantity. So by any chance, the xn plus 1 cannot be lesser than xn, because every time you're adding something into it. So if n tends to infinity, the value of the limit of xn is L. We can assume the limit tends to infinity, the xn plus 1 is also L. So limit n tends to infinity, at the very large number n, the limit of xn and the limit of xn plus 1 should be the same. So I can substitute L there, means I'm just going to apply the limit here, limit n tends to infinity, xn plus 1 half, and limit n tends to infinity, xn plus 5 times limit n tends to infinity by 1 by xn. So what will happen to this thing? This is going to be L again, and it's a half times L plus 5 by L. So we have to find out L. So all that we have to evaluate the value of L. So I can write 2L, not 2H, 2L is equal to L plus 5 by L. And of course, it is going to be a quadratic equation. So it will become 2L squared. Rather, L square is equal to, you see here, 2L minus L is L. So L square is equal to 5, and from there L is equal to root 5. So option B is correct one. The limit is going to be root 5. So these are the two options we have, because the C and D are just the other versions of the same value, which is not going to be correct. Now we go to the second question. We have given two statements. The statement 1 tells that let OABC be a regular tetrahedron of side length unity, where O is the origin. If P is a point at a unit distance from origin, such that OP is equally inclined to OA, OB and OC at an angle alpha, then P1 is equal to cos square alpha. Okay, so basically here the P1 is not any length, it is the value of alpha. When you find, not value of alpha, when you find the cos square alpha for any given angle alpha, then whatever result comes for the cos square alpha is P1. It means our aim is to find out alpha so that all the previous data will be consistent. So let's try to construct a tetrahedron and try to understand the whole situation. So I have, this is a tetrahedron. I'm just constructing randomly. I have like this, and let's say this is the point origin O. This is the first vertex A, B, and this is C, so that I can take three different vectors along OA, OB, OC, and I can join this also to construct a new nice looking tetrahedron. And there's a point P somewhere in the same setup whose distance from the origin is 1 unit. So let's call this vector OP vector is a small p vector. Now don't get confused with this P1 and this P2 here in the question. The P vector I'm just assuming. I can assume the other vector, but it look nice. So this is going to be U vector here. Let's say OB is V vector and the OC is W vector. Let me write. OA vector is U vector. OB vector is V vector. And OC vector is W vector. Now the question tells that the OP is inclined to each of these U, V, W vectors equally. And the angle between U, V, W, how do we identify? Because this is an equilateral triangle tetrahedron we have made on. So each side of length 1 indicates that if I find U dot V, suppose I'm finding U dot V. So U dot V is immediately we can write the mod of U, mod of V, and cosine of the angle between them. And cosine of the angle will be always 60 degree. So U dot V will become half. And so the U dot W, and so the V dot W. I hope up to here it is clear. Now I have to introduce this OP vector or the P vector with UVW so that we can find out the angle alpha. So what we can think, the OP vector has the length again 1 unit. It's already given that the magnitude of this P vector is 1. It's also unit vector, and all these UV are also unit vectors. So suppose you want to find out the angle. How do we find? How we can use it? So we know that the P dot U, I can say that the magnitude of P, magnitude of U, and cosine of alpha, because alpha, they are saying that they are making alpha. And these are unit vectors, so you can write cosine alpha. Similarly, P dot V vector is also cosine alpha, and P dot W vector is also cosine alpha. Now there's one simple temptation the students may have, that if I have a cos alpha, cos alpha, cos alpha, and each is the unit vector UVW, I can use that cosine square alpha plus cosine square alpha plus cosine square alpha is 1 by using this fact. When any vector is inclined to the axis by unit angle, I can use the fact that the cosine square alpha plus cosine square beta plus cosine square gamma is 1. But here, please notice carefully that this is the p vector inclined to, of course, to unit vectors, but these unit vectors are not inclined at the 90-degree with each other. So they, by any chance, they are not constructing any analogous system as our coordinate system is constructing as x-axis, y-axis and z-axis. So here we cannot apply the same thing here, what we apply usually, because UVW are not constructing the what we call the mutually perpendicular system, although they have unit vectors. So we cannot apply this. So we have to think a different way to find out alpha. So what we can think that the OP vector, how can we write? We can see that thing, the OP vector or the P vector, what you have assumed, is equally inclined to UVW. And the UVW vectors like OA, OB and OC are in fact non-coplanar vectors. And since the P vector is equally inclined, I can write the P vector as some linear combination, but since they are equally inclined, I can write the P vector as U plus V plus W times, means lambda times this U plus V plus W. Let's assume this as 1. Now by using this fact, we can apply the U dot P dot U, P dot V and P dot W. So let's do this with P dot U. So if I do with P dot U, I will get lambda times U dot U will become 1, and U dot V, if you do that, will become half, and this is also half. So it will become half plus half. And P dot U is already cos alpha. So I got cos alpha is equal to lambda times 2. It means I can write lambda is equal to cos alpha by 2. We can also use the same fact for others, but it will give you the same value. Means if you apply with the P dot V, you will get the same value for the lambda, or the same equation you will get. But notice one thing, this gave the value of P, means the vector P, in terms of alpha. So P vector I can write as the cosine alpha by 2 U plus V plus W. Now you know that the magnitude of P is 1. So we can directly say that magnitude of P is equal to cosine alpha by 2 with the magnitude U plus V plus W. You notice now it is indicating that we are going to find out cosine square alpha, because when you square both sides, that will become 1 only, because magnitude of P is 1, and this is cosine square alpha by 2 in front, and this is going to be U plus V plus W mod square. And you notice that to find out U plus V plus W mod square, there is no such big thing, because I can just rearrange everything, and here I can write twice of cosine square alpha. This is going to be mod of U square, mod of V square, mod of W square, then 2U dot V, 2V dot W, plus 2 u dot w. Even you don't write, you can directly mentally calculate it. So this is going to be 1 plus 1 plus 1, that is 3. And this is also half, because each of this quantity is half. So this will become again 1 plus 1 plus 1. So that will become again 3. So cosine square alpha, what I'm achieving is 2 by 6, that is 1 by 3. Therefore, I had to square, so that will become 4 by the way. So this will become 4 by 6, that is 2 by 3. So cosine square alpha we got 4 by 3, that is P1 is 2 by 3, not 4 by 3. P1 is 2 by 3. I hope it is working. Yeah, so P1 is 2 by 3. Now I'm going to analyze the statement number 2 and see what is going to happen. So the statement 2 tells A, B, C, D are 4 points in the space and satisfy AB is equal to 3. So let me draw, I think it's a quadrilateral. So let's draw it. Base and AB, okay. So I don't know how this look like, is a parallelogram or quadrilateral. Let's first draw roughly AB, CD. The lengths of AB, CD are given. So AB is 3 units roughly. BC is 7 units. CD is 11 and DA is 9. And they're asking that the angle between AC and BD, means angle between diagonals, are given. So AC and BD, I have the two diagonals and the angle between them they're asking. Because why they're asking this theta, so again you have to find P2, means you have to find out cosine theta. So you notice there's one property we have, that you can see that what is the property. If this let me just write it, then I will write. So I can say that what is, you can notice there, the CD square plus AB square is equal to AD squared plus BC square. Is it satisfying? Let's check. 11 square plus 3 square is 121 plus 9, that is 130. And the right, this is AD square, right hand side is 9 squared plus AD square plus BC square, 9 square plus 7 square. So 81 plus 49. So again 130. It is satisfying. So if this happens, then this diagonals are at right angle. Then I can say AC dot BD becomes 0. You can prove it by just assuming these vectors. Let me give another thing what I want to say. It is, in fact, if you write AD squared plus BC squared minus CD squared plus AB squared is equal to twice of AC dot BD. This is the equation, and by using this equation you can notice that this is already 0 on the left hand side. This I can say that AC dot BD is 0. How we prove it? In order to prove, we can I'm not going to write the proof because not so difficult. I can assume these vectors, position vectors B, C and D. So you can prove the left hand side by taking AD. AD means that D minus A mod square, and again BC. So you can simplify and you will get this thing. One side you can simplify. You cannot do it from scratch until we have to establish the equation. How do we know that it is going to be? So this is the question based on your memory. If you have a good, like a command over this kind of geometry and such formulas, we can do it in quick time. So from there we got that cos theta is going to be 0 because theta is 90 degree. So P2 is going to be 0. So that thing what we have to find out, the 3P1 plus 2P2, the box of this, and 3P1 is because already I have found P1 is 2 by 3. So this will produce an integer 3 into 2 by 3 and plus this is 0. So the answer is going to be 2. All right, let's go to the next question. And here notice in any such kind of question, if they're giving this kind of thing, here x to the power 2r by r factorial, there must be r also. I think the picture I got as a doubt, in that picture the r was not present there. Means the question I received there. So there's a mistake here. That must be r there. Otherwise, none of the options will come as the answer. And it is but natural to understand because they will not introduce here this log and everything and make it complicated. So we are assuming that that should be r. There was a typo mistake in that question. So let's first evaluate this top numerator thing. And numerator, I'm going to evaluate only this part. So this is e to the power ix cos x minus I sine 2x. And this e to the power ix I can write cosine x plus I sine x, which is multiplied to cosine x again. And this is minus I sine 2x. Now notice one important thing, that when we multiply here again, we'll get cosine square x plus I sine x cosine x. And here minus I sine 2x. From there, what we can do, I can write here. Well, I think it's not a wise step to do this thing. I can directly say in this way. Or let's do in this way only because already I have moved so far. So what I'm going to do is, this is cosine square x only, and here half sine x cosine x, and this is going to be 2 sine x cosine x with I. Now notice from all these terms I can take cosine x common. So we get cosine x out, and I'm getting here cosine x, which is independent of I. And from these two terms, I have already taken the cosine x common. So I'm left with I sine x minus 2I sine x. So I sine x minus 2I sine x will give you minus I sine x. And that's all. Because this will now lead us to cosine x, and this can be written as e to the power minus I sine, ix rather. And you notice that if I can write this whole thing as e to the power minus ix, this top will become, so the numerator is directly what? X to the power 4, e to the power ix, and this whole thing is cosine x times e to the power minus ix. So you notice if you club these two together, it will become e to the power 0, that is 1. So numerator is only x to the power 4 cosine x. Now let's go to the denominator of the integrand. So denominator is also not so bad because this is log and this is summation. R goes from 0 to n, and this is x to the power 2r divided by r factorial. You notice that this entire sum is going to be the argument of log. So we have to first evaluate this sum. It's not a difficult task because you notice that this is going to be, the first term is 1 because you put r is equal to 0. The second term is x squared by 1 factorial. The third term is x squared to the power 2 by 2 factorial. Then x squared to the power 3 by 3 factorial up to infinity. and it is not a difficult work to identify that this is nothing but the expansion of e to the power x squared. So this I can write the log of e to the power x squared, and that's why the log is given in front, so that the x squared will jump off and it will give you x squared only in the denominator. So our integration will turn into an easy integration now. Negative pi by 2 to pi by 2 x to the power 4 cos x divided by x squared dx. So I got this thing, and from there we have to evaluate it. So we have all the technique, you know how to find the integration, but let's try for the sake of completing this question. So that is going to be negative pi by 2 to pi by 2, and this is x squared cosine x. You can identify that this function is an even function, so I can write the limit as twice of 0 to pi by 2, means whole integration x squared cosine x dx, and after that we can apply the integration by parts. I think you will get this integration, and after that we will simplify. So that is going to be pi squared by 4, sine pi by 2 is 1, cos pi by 2 is 0, and again sine pi by 2 is 1. So this is going to be minus 2, and at 0 every term will be 0. So this is going to be pi square by 2 minus 4. But I have to find out the L, okay, so this is L, not, okay. I have to find 2L. So 2L is going to be twice of pi squared by 2 minus 4. So my answer is pi square minus 8. So this is the answer. Alright, so that's all for today. There are some other questions as well. So we will discuss those problems in the next video. Till then, stay math active.